Yes, shall we start?
Go for it.
So this presentation is going to be about some views that I have about recommendation systems after visiting Hong Kong and recommendation systems conference, which was held there, and which was exciting event. So first of all, I would like to, to define what, or ask the question, what is the recommender system and what this conference was about, or what is this, so it has its own conference, or what this conference was about really. In my view, maybe some other people will have a different view. I think in the center of everything in this conference was the system of this sort of structure that we had presentation already here about such a system. So basically we have some users, some items. Users can rate items, and users are some entities in the system with some additional information about. So like people, but it can be more general thing. It doesn't have to be people. It can be matching like items to items, or documents, or different things. So I believe this is what is in the center of what I'm gonna talk about. And what's amazing, this simple structure has a lot of impact on really what's happening in IT nowadays. So I'm gonna show here that big companies like Google, LinkedIn, Facebook, they all interested in the systems that are built around this structure. So that's basically the subject. The subject of the whole conference. So I would like to move at first to tell a bit about the conference before I move to some details of what they said about this type of systems. So the conference was held in Hong Kong. It was more scientific conference around the system that I introduced, but because those systems exist in real life and they are very, very close to our life, our everyday life, really. It had also a lot of commercial taste, I would say. So it wasn't like very typical scientific conference in this sense. So it was not only studying the systems itself and its theoretical aspects, but also some more broader aspects like social aspects or practical aspects or commercial aspects, which I think made it more interesting, and more interesting, for example, from our perspective as a part of industry, really, here. And I think it was one of the good, sides that I attended this conference. Well, that wasn't, totally expected that it's gonna have that much of the commercial aspects. So, organization of the conference, it had a typical scientific conference organization. So it was weekend of workshops and tutorials. Then during the week, couple of days of keynotes, technical session, poster session, like gala dinner, so typical scientific stuff. But on top of this, there were some demonstrations. So people talking about the actual systems that they built for the research, and not only for the research at universities, but also for the research, for commercial research. You could play with some of the, like the guys were showing this, and also it was industry panel with some guys from industry. There were many Chinese guys. There are like, I think those companies, there are like some Chinese news and some IT provider, so like big Chinese companies. So what they were talking about during the conference, and this is my sort of view, like for the purpose of this presentation, to summarize the aspects really of recommender systems that were touched during the conference. So the first aspect that I recognize, and I will give example in this talk, is around methods and algorithms. So this is the scientific aspects of the conference. So we have the recommender system as I introduced it, and the people studying different methods of predicting ratings, predicting matches, and then ranking items, which is the part that I would like to talk a bit more, because I think that's maybe relevant to some of the applications we have here, like having displaying basically the results from the search or from the from the match on the web, basically, where you're interested in top N items, basically. So that's this subject, basically. And it was the whole workshop about methods, how to basically order items for the user, which I'm gonna go through in a second. And then another aspect of algorithms is how to use the metadata about users and items, because most of the research is focused just on rating predictions and ranking items, but based on the previous ratings and previous rankings. So this is what researchers study, because it's sort of simpler problem. But we have also some additional data about our users and items, basically. So that was also a big subject of the conference. So that's the scientific part, really. So we studying here like a bit like parts of the problem, really, parts of the system, and try to improve the methods, which I will show on the example of learning to rank some sort of like the flow of or evolution of the subject over years. Okay. Another part is the actual applications. So I will give some examples of the recommender systems that actually work in real life, and some libraries as well that can be used to build your own recommendation system or integrate it with your application. And then in the end, the third aspect that I recognized on this conference is like between application and science. So some social and I called it philosophical aspects of the recommender systems, and I gave some examples here. With the first one particularly interesting, which I will talk about more because it was quite interesting talk. So that's for the end of the presentation. So let's start from the example of the method and how the science around recommender systems evolves. I try to go a bit shallow and briefly because it's quite heavy, and I must admit that I don't understand everything that is behind. What I'm gonna talk as methods, it comes from the workshop that was, I think, held on Sunday or Sunday by the guys from Telefonica Research in Spain, and basically Telefonica is the BT in UK, I guess, but in Spain, and they owe the biggest social network for Spanish part of the world, so big part of the world, and they have some various other things. And as a research, they interested in learning to rank items basically, and they have quite long list of contributions, including important algorithm for ranking items. So it's maybe I will reintroduce the what's the prediction of ratings rankings is really about, because I know here we're using something for rating things anywhere, I guess, yeah. So some concepts with information retrieval, and because we are using here Apache Solar, isn't it? Yeah. Who uses it? Who knows? Who's familiar? So that uses that rates items basically. So this is the same context that I'm going to talk about here, but it uses basically rating as some numerical number to numerical value to order items based on this. While those guys they going a step forward, so they actually learn the model to give all the items, list of the items, rather than just assigning numerical value to it. So what we're doing is just predicting point, rating, while you can go much farther and get 30% better performance. So that's basically state of the art. So yeah, this is a quote from the talk, but those numerical ratings are not always ideal, and they also require to give the rating to every item really, rather than just those that are linked to the user. So this is what I just said. They want to learn how to rank, so how to give the whole list rather than just assign ratings. What we're doing is with Apache Solar is standard information retrieval thing, and then they also gave the analogy that user item thing is the same concept as query and document from information retrieval. So our user if we want to give him like items, show the items, so our user or his personality or his previous history is like a query in our system. And yeah, and another thing is that in a standard query document setup, we just measure precision or recall, or we just measure how many relevant items we gave, and from all the items, and in the actual ranking problem, we may be interested in more in where they are actually. And this is a very important actual problem, that I want the relevant item on the top of the list. So I want like first, second, or third positions are more important than last bits, because I just get my recommendation. I don't know. I'm looking for a job, or it's a dating site, which I'm gonna also move through. Then I'm interested only in one match, for example, and it's better it's on the top, not at the bottom of my query result. So so it's all those things they take into account. So that's a bit more than just query, just a retrieval problem. Well, it is still a retrieval problem, but it's like a step forward in the retrieval. So what their contribution was is using like basically different measures of the performance of the system, and the like state-of-the-art measure is called normalized discounted cumulative gain, which basically assigns more value to the first items in an exponential way. That's the shortcut. I give references, so I try to avoid equations. So that's basically a ranking problem. So to summarize the methods of ranking is we can use this just a simple classification methods, or you can or we can expand it up to like full learning the full set of items. And I actually maybe show the slide from their presentation, because that just gives a bit more better view. Yeah, so that's this normalized discounted. That's going to be so that's basically this is on my list. It's these are these three approaches to do this ranking. Either we just learn based on user and item, we just give a numerical value, or we actually get the whole order for all the list of items, which is like details are a bit more tricky really how to do this. But this is basically the flow, like how the research in this area is going. So that was that was what I wanted to really show here. And then they're working on some different metrics for performance, and they trying to add some metadata, so some context to to the model, which is not trivial really. So basically use, I don't know, the text of review, location, on top of the previous ratings, or yeah, on top of previous, or just previous ratings. And that was also like a big session around context in recommender systems. So that's one example. I promise that's the heaviest bit, but still very shallow. But yeah, it can be useful for what we're doing here. So that was like the research in the actual method. So okay, we have our method of ranking or rating or whatever it's our need. And now we want to actually implement it in our application, which is more interesting for us. And we had also our metrics to measure like whether our recommendation is relevant, accurate. So we had this cumulative gain metric or some other metric like precision or recall. But that's not enough, because in real life we have a range of new problems, and they are actually more serious. So scientists, they study like another method, improve mean squared error or normalized cumulative gain, which is like state of the art. So they optimize the normal cumulative gain. Then they not happy with normal cumulative gain anymore, so they introduce different metrics. Like, so all the stuff that I said previously, this is the picture basically. But in real life, actually, that's not enough, because the range of new problems arises. And the first, as I already mentioned, is well, we want our recommendation is within some context, or at some point of time, at some location, and that already causes non-trivial problems. But there are more problems. We want to have like diversity in our recommendation. We don't want to recommend all the time the like most popular items because this is what our algorithm gave. Yeah? We want to increase the variety. Well, so basically all the items are sold. Yeah, like as many as possible, not just because users want users, like they're interested only in popular ones, and they don't. So then they're gonna be recommended by the model only popular ones. So we want to diverse. We want to show the new options as well. So make it interesting. We want actions after a recommendation, which is also an important thing and which can be measured in the system. And this is also, like being studied. Actions, we want to be able to understand why the recommendation is what it is, or why the ranking is like this. And user wants to understand often this, but more the developer wants to understand this. And this was the point of, I think, industry session there, that as a developer we want to know why this was ranked in this way. I guess this is the problem that I saw here already. It's not really, it is really important, like why this algorithm gave this recommendation, which is nonsense, for example, in particular context. But somebody complained, for example, that got this recommendation, and then what to do. So that's really important. Another thing is like that they also were talking a lot about serendipity. Serendipity? Yeah, this is how you spell it. So I think that's possibly related. So you have to be happier, yeah, after the recommendation. Or or maybe it depends on the application. Yeah, if you want to put people off, then maybe more. But yeah, it has to immediately. Like user has to appreciate this. Yeah. Then it was the concept introduced at this conference, which was quite confusing, I think, which I didn't get. The guy called it neutrality. So I think the concept is like that the recommendations are neutral in some sense. But he gave mathematical definition, which I think people from the talk, they questioned this. But that's okay, that's another idea. Yeah? And then, okay, if you have this additional things, we want to be able to validate and well, test basically our system. So we have offline testing with metrics basically. This is what we can do offline. So this is what we can automate just by using metric and having target for metric or something like this. But that's not enough because we want to test those things that are not measured by anything. So then we need some sort of like online testing with real users, and this is what people are doing all the time in science. In science they like it, especially in social sciences, to set up the experiment, ask some students, ideally, to give some feedback. So we have like online either experiment or we have online on the real life systems. So there were guys from LinkedIn there during the conference, and then they can afford this. They have a lot of users, so they're doing a lot of live experiments. And I was a bit jealous when some of those guys were talking that, oh yeah, like it's easy to test it because we can just plug it in, yeah. And this is what they're doing actually. So. Which is maybe a bit scary, but they actually, testing on us. This is I'm not like really joking because this is the guy from LinkedIn, talking. I'm just really repeating like what he said, but this is what they're doing. So. Just talking about LinkedIn, I want to actually talk about some of the commercial ways of dealing with those recommender systems. So I picked like as an example because these were the sessions I attended actually, dating and job search, which are almost the same really.
What are you in? A job search is less critical, really.
It's less critical, yeah. I think there are going to be different opinions about. There are a lot of commonalities, yeah. And this thing I really like one of those guys. I think I mentioned it a couple of times. It was Keynote about. Basically a Chinese dating portal, very specific one, and the guy giving this keynote, one of the directors, I don't know whether it's CEO, maybe I just made it up a bit, but but he actually said that he met his wife using this portal. Interesting, yeah. And I mean, like this is the same problem because of this thing that I particularly like. There is something called stable matching problem. I don't know you. Yeah, you definitely heard like stable. Yeah, everybody heard about stable matching. I think it's called stable matching theorem. Yeah.
Yeah.
So basically, the thing is that if we have some users and items, and if every user rates items from 1 to like gave the rating, like ordered them like from 1 to n, like as many items are there, then there is always stable match exist. So stable match is something that you cannot basically improve it, because if you take So we can think about this as like girls and boys, yeah, and marrying each other. So that there exists like configuration that if they marry, then if I want to pick another girl, then I'm not gonna be high. I'm not gonna be on the top of her list, basically. Yeah. So I always, but I'm gonna be on the top of the list for the one I found. So there always exists a stable match that that basically it's not gonna. Nobody's gonna find the better match. Yeah, it's something like this. Yeah.
So it's
I think
optimal.
it's in the sense. Yeah, in the sense.
In a sense, there's no possible situation where somebody could find somebody who they prefer and somebody prefers them as well.
Yeah, so
there's
there's no such a
going
situation. So it's in the sense stable. Yeah. So that's and also that's like that's basically the idea of all those portals. Yeah. So yeah, that's what they aim, yeah, really, to give you the best match. So recommendation in their case, it's like the core of the system. This is what they like really business is about. Yeah? So not surprising, they're doing a lot of research and a lot of effort in putting a lot of effort into it. And I'm actually gonna give like what the guys in LinkedIn are doing, because I was like brainwashed by them. I think there were 2 or 3 presentations I attended with the guys from LinkedIn. Yeah. So another thing with dating and job searches is that evaluation is not immediate. So the actual connection, like caused by the system, yeah, is gonna happen maybe like in job search or like or dating, like the marriage will happen like maybe in 2 years, but it can be actually triggered by the system. Yeah. So how to know this really? Yeah, it's not that easy. While with the e-commerce, then okay, somebody bought it. I can track the funnel, and I know that it's because of recommendations. Here it's difficult. So that was another point, that we don't care if on our list of top matches there are irrelevant items. We want relevant, but the relevant is not enough. We want the best one. Like if it's relevant, if I pick it, then I don't want to be rejected. That's very important. If I and this guy from this Chinese guy, he was telling that like they actually do have complaints from users. they do have complaints, like if the on recommendations. So that's interesting as well. Yeah. And I don't think he was only one who was saying this. Who was actually saying that the users do complain about the recommender system not working as expected, or giving bad recommendations. And in job search, that may be more serious. Yeah, if the match is wrong, it has major effects. Yeah, in dating sites there were some maybe things maybe not. Well, they may be also relevant to job search. Yeah. And then there is a problem that your recommender system may be favoring some scammers because you have more data about them. And rich data. Yeah. So the insights into LinkedIn, what they're doing, because I think that's quite interesting. So because I think everybody uses here LinkedIn, yes, that's correct. So they basically do have strategy, and they're saying this openly, and that's, I think that nobody's going to be surprised, to close the graphs basically. So create denser links between people. So like everybody is linked within, for example, community. So I don't know, within Black Pepper, everybody is linked with everybody. So this is their goal. And they use recommendations, and actually the recommendations really help them. the guy gave like a figure. He said actually that's 50% of connections that that are made by the people you know featured. Yeah? I think it makes sense for me at least. And so that's one of the strategies. And then on top of this, what they're doing. So everybody will stop using LinkedIn after what I'm gonna say. Well, what they're doing, they modeling users actually, like for job search and job matches. Yeah. So they do things like called behavioral lookalike modeling. So they basically try to classify people, and then they're doing this. And then they also model things like they're interested in things like when people are switching jobs, which was actually quite exciting because it was quite like bigger, longer bit of one of the talks that they were basically, the guy was showing like the models of job switching, and I think he was talking about IT profession, so like depending on like how senior you are, on age, and he did this modeling, and then they were modeling job seeking as survival modeling. So basically, leaving job was as death, which can be also applied to like dating. And they studying all this stuff like with survival models. And I think they have like paid service as well. Yeah, I don't know, for like recruiters and do they? Yeah, because he was talking a lot about this. So they're doing, I guess, all of this stuff because they paid for it. Doing this. This is their source of income. But he also talking a lot like that they're actually doing this stuff, and also some optimization for the problems like when not to show. So I don't know, like not to recommend the company that you just left as in your job search, for example. Yeah. That was the example I remember from them. Okay, so that's basically like one of the commercial sites, and then I also saw like a lot of ideas basically done purely at universities, and then I picked a few because I think some of them they have some commercial value, but I don't know, I didn't see really. It wasn't clear really whether they went with them somewhere forward, but it maybe somebody bought it, or I had a bit of like discussion on offline with some people, and some of those things they can, maybe they are somewhere. Yeah. So one was the guys were actually showing the like full prototype of an app that basically recommends events for you, and then recommends who to invite to those events from your friends. So something like this, and actually working up here. Then another guy, they were studying, there was German guy, they were studying gestures for rating on mobile apps. So they were basically studying which gestures people are more keen to use. Yeah. So they did like user study with this. But that sounds purely academic. But the guys seem to be like, and they also created like an app and the full study. Yeah. It's by the way, like for all the stuff I'm talking about and much more, I somehow can share all the papers and materials. It's all it's paper about this, paper about this. So, then another testing framework by some university for TV and movie recommendation, which is I think the origin of all this like research around recommendations. And then there were some, crazy ideas like recommendation in augmented reality, and it's like the guy who was basically, they were studying whether it's better it's better experience like the virtual reality shop and recommendation within this than like standard website thing. There's also paper around this. So that's basically a range of like research ideas, and it's actually quite an interesting pattern around like the research ideas. That a lot of research is actually studying the actual system within a controlled environment, while it's like I haven't seen any like big company doing something like this. I guess they just study this live with their systems, or they do this like they don't publish it. I don't know really. So that's the second part really. That's the like applications and issues.
I'm sure Google Glass are doing that, aren't they?
What?
I'm sure Google Glass are doing recommendations in augmented reality.
Yeah, they
walk around and see
possibly,
adverts
yeah.
floating everywhere.
But I'm not. But this thing was just not also like also university. It was purely academic. But they there's this big cooperation between universities. I'm gonna summarize. So I'm gonna mention this. Yeah, like arts from that's something like this. Yeah. So another point like I wanted to like really talk like about is that actually all the stuff. That's why so many like researchers are just like studying this, because there are tools available. You can just build it, and it's not that difficult as I still thought a couple of months ago that it is. There's actually a lot of possibilities to basically have a system like this with your application or with your system. So yeah, where I was a couple of months ago is just machine learning libraries. Okay, there are libraries available. I am talking about those that were mentioned, at least at the talks I was there. It's quite interesting because this one is from Microsoft research in UK, in Cambridge, which is basically has all the like, inference algorithms. And then those guys from Telefonica, they were talking about something called Okapi, which is like which is more like a recommender framework on something called Apache Giraffe, which is the tool basically to work with big graphs. But this is just a project that started, and they just advertised it. But I heard about this, so I put it. And yeah, Apache Mahout, that's possible. Like, I think that's machine learning framework. But then there is another step. Because if you want to use Apache Mahout, okay, you have to build your API and you have to plug it in. You have to build actual recommendation out of the algorithms that are there. So that's not a recommender system. So it's a lot of effort really. But there are actual recommendation solutions. This one I heard about, and a lot of people use it. So it's becoming, I think, or it became like standard in the community of recommendation system people. It has also like a RESTful API, which is quite well defined and. Okay, and then there were another thing that actually you can plug services on your web page. There are possibilities of doing something like this. which I understand it works very similar to things like Google Analytics. So you can just put JavaScript snippet, and it works. And I found maybe you know, if you look a bit more, then maybe you find more. But I found like this one like is interesting, and okay, this one is I made a sort of friend with the guy who is MD of the research for them. So I put it here, and they have like trials, so it may be something worth interesting to try, like this or this. And well, this one I actually saw in action. That's another thing. They have also RESTful API, and you basically, he was showing how to integrate it with WordPress page, and you just put like short snippet of JavaScript, and you have your recommendations, and it works. And then another interesting thing was the guys from BBC Research, that they built pure JavaScript library for the recommendations, which you can just download and play with. I haven't done it yet, but it may be interesting to play with such a library. He said like what kind of methods they use. It's like very basic and simple recommendation, and it has all the limitation of the client side, so it doesn't persist information about users, so you only have recommendations during your session really. So that's basically integration, and okay, I wanted to like go through this philosophical part as well. Because okay, once we have integrated our system, we enter in this world of all the problems around. So one is privacy, which is all the time a big topic. So, and it's actually I'm gonna summarize with some thoughts around this. Because that's a big thing, but on the other side, still everybody's doing this. Like, Google doesn't care really. So there must be a reason why they're doing. They're still doing this. And it's actually this keynote of this guy who's studying privacy a lot. He started with saying that we cannot really decide about ourselves privacy. We always get it wrong, and that's known thing. And the more we want to keep privacy, the more, or general trend is like this, the more we disclose. So all the things like giving people control is it's not necessarily a solution. So this, I think I want to go through it a bit quicker. It was quite interesting keynote because he gave a couple of interesting views around this, how we look at our privacy, and they were doing some experiments like auto-filling forms. Yeah. So how much detail? Well, if you fill automatically your form, you give a lot of details to wherever you register, yeah? And actually that's true that people don't like it really that much. But actually the people are really keen to fill the form in full if they have to press button next to each field, which is a bit surprising. They studied it basically with real users. They really much more because they feel in control, even that they give still the same thing, and they put a lot of effort. Yeah, so people were like a bit questioning this, but that was they researched this. Yeah, that's a known thing. And another experiment was to give. He was giving different. About different levels of privacy about your location. So you give no location, you give your city, your block and street, and exact location. Yeah. And then they did another experiment that I think they had more or less of the options, and people always like just tend to choose the middle one as like neutral, so you can manipulate it in any direction really you want. And okay, it seems you have the choice of privacy, yeah, but that's not really true, yeah, because you can easily just give no choice in this way, because people tend to choose middle one because they think that that's safe option, but it can be, it's just middle one, so how you label it is up to you really. So yeah, that's the conclusion was like more control, more transparency, and there is still no way that people will make rational decisions. Yeah? And the other thing was that he was talking was about default option, which default option is better or is more effective. Yeah, they actually like found out like having something like please do send me. This is more effective. And then another thing was about this concept of like asking questions for disclosing information. So if you start slowly, then you can make a person to disclose more. Yeah.
Your last question, they answered that one, so they might as well answer the next one.
Yeah, that's something like this. Yeah. So that's more it gives more the disclosure than this. And this is called like door to the feet or something like this. That when you start very heavily and then go down. Yeah. But what he is proposing as a solution is to basically model a privacy with recommender system. So learn what are the needs for the person for their privacy. Basically learn it. Yeah. By using machine learning and models. So this is what this guy is studying, and he's sponsored by Google. Which is a bit, yeah, I'm laughing because that's a bit, I'm not sure whether it's that much for the privacy, but... okay, and interesting from the talk was that Facebook privacy policy is longer than the US Constitution. Okay, that was one of the aspects. Then another philosophical aspects. So this is what I wanted to come back to. As it worked, okay, yeah, it introduced those risks that somebody will complain that you're storing too much information or something. You have all the time those like offers with Facebook or Google, but for whatever reason they're still doing it. Well, because it increases sales, and that's proven thing. And they were talking a bit about this, and in the papers you see. I guess this is the question that I think Sarah and John asked me one day. It is written in papers, and it actually does increase sales by like big margins, like 20% or so or more. So then it was another, like. There were guys talking about advertisements as advertisements on the web. They also sort of recommendations, yeah. So are they really a bit different, but they're still recommendations? So those things, they come together. Are they really bad things or good things? Maybe. This guy was claiming that this maybe I agree with him a bit. That maybe that's a good thing if you have right adverts, because that's maybe it's just like suggestion, yeah. If you have some rubbish online, like stuff, then maybe like you're offended by some. But if it's relevant, then maybe that's a good thing. And then also there's a lot of a lot of available data to study the systems, and privacy comes again here, and you can get even more data. And there was also a whole session about getting data from the web, basically, which is available, and people do it, and the researchers do it. So yeah, to conclude, really, some of the points to put those things together is well, everybody wants really recommendations. we seek for recommendations every day. Yeah? We want recommendations. It often makes our life easier when we got a recommendation about something. We don't have to do all the research. Then recommender systems are part of the really social systems, yeah? or there are different aspects. So which makes it difficult to give recommendations, because Facebook is not all my life, even maybe for some people is. But I'm doing some different things, so my personality is a bit richer than myself on Facebook, but it's Facebook giving me some recommendation, or I know Amazon, just only based on what I did on Amazon. So that's not enough, and maybe it's gonna recommend me something that I already bought. Yeah. Then another thing was about the evaluation, which is known that it's tricky, and then here it comes, really the role, like what academics do and what in industry they can do. So in academia, it's very easy to overcome all the problems with privacy. We can basically say it's academic study, so we're studying everything about our users. And those examples that I shown from like academic research around recommenders, and some other things that I saw, like like about things like tracking students or people participating in study. Yeah, you can do much more, because people trust much more, and so you can study much more. While when it's like industrial system, maybe they trust less. But on the other side, if you have a big system, then you can just try yourself like bigger scale experiments. So this is what both sides are doing really. I mentioned this, that you have to be careful with bad recommendations, which they were talking about this a bit, like including the guys saying that they actually do get complaints on the recommendations. Explainability, I think that's important, for example, like and that's mainly from developing point of view. The guy who was talking about this, I think that was on industrial panel, said like that's very, that can be really big problem if I just plug black box and then I got complaint. Yeah. What you gonna do? Nothing you can do. Yeah. So it's important to understand why you getting like results. Then we have already like really lot of solutions that we can plug into our system. And at the conference they have wiki with quite like comprehensive amount of material, so including links to data. And I need some way to really share the data from the conference, like here, because I think it's useful, so everybody can have access to papers. I don't see any reason why not. It's not like this. I just get this, so it's not written, no disclosure or something. So yeah, that's basically it. Yeah. Thank you. Yeah. Any comments, questions, suggestions, recommendations?
Are you aware of any good papers reviewing some of the systems that some of the big e-commerce, like Amazon? I know the algorithms are going to be secret, but has anybody studied any of those systems and how they operate?
Actually, I think that's not completely true. I don't think the algorithm really, that some details they're using they're gonna be secret, but algorithms are known. So
because it would be interesting comparing the mathematical prototype with the social, because the interface between the two. It'd be interesting to know to what extent Amazon really works. Obviously, I personally find it quite useful, but I don't know if there was any academic work on any of those kind of recommenders.
There are white papers about Amazon, like that Amazon published themselves. I'm not sure about what's the most up to date. I have even some about Amazon recommendations. So they use some version of collaborative filtering, but they have a bit also more problems because their systems have to scale. That's big issue. And I guess you know that's the thing that if you work with Apache Solar or something like this, you may observe this as well. That it's relatively easy to have recommendation if it's on the small scale. If it goes, you know, to millions of users, then you know, like you have to do clever tricks if you want to use something like matrix factorization or something. It's really becoming serious, and everybody there that I talked to them agrees with this. Yeah. This guy from YouTube, he said like, yeah, it's easy. You can just build and plug the algorithm even, and it's gonna be all right. But to make it scalable, it's like think twice. Yeah. You're not gonna do this yourself. Yeah. And he said, yeah, like this is like years of work what they did. So yeah, I think that's.
I mean, it would be interesting to see. You know, there was a slide that you had where how you enrich the recommender system. I mean, I'm sure mathematically I could, you know, depending on how my users are purchasing on an e-commerce site, I could have some notion of the optimal, at that point, recommendation for their next purchase. But if that's stale and, you know, it's so lopsided, as you were saying, it's always recommending the top one, so how much difference would it make if I slightly enriched it so I get my users were able to purchase things which they may not have thought of.
Yeah, that's exactly what they studied. Yeah. But and these are big things. It's for example when I talked about LinkedIn. Yeah, it was a lot of presentations. It was not just one presentation. So they have different departments working on this stuff basically, like and scientists and so they think about all this stuff. You know, like, and then they study all the details. It's if we want to do something like this, then we have to rather, you know, like build on, like find our starting point really, like somewhere high, yeah, and then, you know, like accept some of the maybe, you know, some things that are not gonna be ideal, yeah. So yeah.
Thank you very much.
Yeah, thanks.